Hello. Let me introduce Philip. Philip is going to talk. Just a second. He's going to talk to us about writing queryable APIs with MicroProfile and GraphQL. Phillip Kruger, he's a software engineer at Red Hat. Oh, he's a colleague of mine. So he's in South Africa, if I'm not mistaken. Is that correct, Philip?
Yeah, I'm in South Africa.
Oh, nice, nice. So let's see if you can start your share screen. Then Philip can he introduce himself?
So entire screen.
All right, so see it.
Okay.
Can you?
Please.
Okay. All right. So Philip, the stage is yours.
Thank you.
After that, we can go into back with Q&A. So see you.
Okay, thanks. And thanks for the opportunity to talk to you guys about MicroProfile GraphQL. So the agenda is basically going to be, I'm going to tell you a story, specifically my story on how I got to GraphQL. And then we're going to do a quick overview of what GraphQL is. We'll look at the MicroProfile, the process and specification. And then the exciting part is doing some code examples using the small RAI implementation. So let's start with giving you some context. A while back, I was working at a big insurance company. And the insurance company had a whole bunch of smaller companies. So it was this umbrella company that actually had a company that did short-term insurance, a company that did health insurance, life insurance, some wealth management, employment insurance. And these were total different departments with total different IT systems. And then they had a system that was just looking after the broker, because most of the insurance is being sold via a broker. But there was also a call center with a call center system, a website, and a mobile application. And all of these were running like separate companies. And where I was working was in the middle of all of this, in a department that was specifically tasked to look after the client, because insurance is not a pleasant thing to deal with. Typically, if you deal with your insurance, something bad happens. You bumped your car, or you're sick, or you're dead. So our job was to make sure that the client stays engaged and in a positive manner. And we've done that by creating a profile of the client and then scoring this profile. And so create a score and then reward the client for the score. So it's kind of a gamification / loyalty program that we ran inside this big insurance company. It did mean that we integrated with sports clubs, and we integrated with your smartwatch, with your car, even with trackable devices on your car, and even with your bank. And we use that information to build up the profile. And then we integrate with shops, airplane tickets that you can buy, coffee shops, online stores, and we allow you to get discount based on your profile, right? So the point is we did quite a lot of integration, right? Not only to the partners, but also internally to the other business units. Right now, as with any big company, there's legacy, right? So a big part of the system and a big part of this integration happened via FTP. And there were some SOAP services, there were some RMI services. Some of the parts of the system is written in AS400, parts is written in Java. And at some point we decided, right, we're going to modernize the system. And we want to make sure that what we do going forward is going to be ready for the cloud. It's going to be API driven or API first. It needs to be properly documented. And we came up with REST. It's awesome, and it's going to solve all of our problems. Now, the first thing that we did, the website team was busy rebuilding their website in some server-side technology, and they want to show the profile of the client onto their website, right? So they want to make a call to us, get the profile and get the score and show that on the site. Now, I'm going to show you some code. It's not the real code of this company in question. It's just similar to convey the message. So if you know JaxRS or even Spring Web, it's very similar. To do a REST endpoint is actually fairly easy. You have a method that you annotate with @get. You show under which path this is going to be available. And in our case, we just return a profile object. And a profile object was really just existed to aggregate two different backend stores. The one was a person, which we got from our Java system, that contained a whole bunch of information on this person. And the other was a score that came from an AS400 system that shows the score that this person got. And then we aggregate the two together into something called a profile, which we then return. Now, under the covers, JaxRS will take care of marshalling this JSON, this profile object to JSON. Now, as I said, it's quite a big JSON payload because person is quite big, but the web team could pick the parts that they want to display on the screen from this JSON and build the page. So they were happy. And at that same point, a new team started. And this is a few years ago, so this was about 5 years ago, and they were building a mobile app, right? So they don't have server-side technology, and they obviously also have much smaller real estate to display things because the screen of the mobile phone is much smaller than a computer screen. So they said that they also want to use our REST endpoint, but they want less data. They don't want all this data back. So we said, okay, let's start reading page 2 of the REST manual. And we came up with Hatios. And it's going to be awesome, and it's going to solve all our problems. Now, what Hatios says is, rather than returning the big JSON, return a JSON with a URI to where to find parts of this payload. So you can say, this is the profile, you can find the person there, and you can find the scores there, which means the mobile will have to make one call to get this, then make another call to get the person, to filter out all of the person details, because I only want the name and the surname, and then another call to get the scores and to aggregate them. So it didn't really solve their problem of less data over the wire. And the web team wasn't happy with it either, because they have to also make 3 calls. So we said, okay, next page, what about BFF? And this is not best friends forever. This is an architectural pattern called backend for frontend. And what it basically means is the web team can continue as per normal. They call the REST service and filter out. The mobile team will have to create a new backend just for them. That's the backend for their frontend. That backend can make a call to our service, similar to the server-side technology of the website, filter out what they don't want, and then stream it down to the client. Now, the reason why this is important to have network optimization over the wire is because a mobile phone is obviously sometimes connecting with 2G, depending on where you are. So you don't want to stream stuff down the network, which is just going to be filtered out. So the web team was obviously happy with this solution, but the mobile team is not happy because they are mobile developers. They don't develop backends. They don't have the infrastructure to host a backend and the knowledge to build a backend. So what we ended up doing is we added a new method. We called it profile light, and we returned a specific object called profile light that contains all the information that the mobile team wants. So obviously now both is happy. Web called the get profile, mobile called the get profile light, or get light profile. Now, again, at that same time, we had a third-party provider that was building an online shop for us. And the third-party provider also wanted to show the information of this client onto the screen. So they want to kind of do what the mobile team did, except they want to add this, some things that wasn't in the mobile. So following this pattern, we have to now do something like this, where they can do get profile profile light with status, right? Because now they want to get the light profile that only has, let's say, the name and the surname plus the status. And as you can see, this is not a scalable solution, because we cannot go and build an endpoint for every consumer to be able to help them with what they need. So then we said, what about if we go back to only having one endpoint, but we allow you to use query parameters, right? To pass in what is it that you want to include or exclude. And this potentially would have worked, but it's very hard to document, because the include and exclude could be a fairly complex tree that you now have to have some sort of a dot notation to say you want the profile that has an address, that has lines. So very difficult to document and to actually use that. So the users of this API would not be happy. Now, what we've realized at that point is what we have is the problem of overfetching and underfetching. Overfetching means that I fetch way too many data. So that's the example of the person where I want to display the name and the surname, but I get 70 fields back. And underfetching is where I want to display the person and his scores, but I have to make a subsequent call to get the scores to have all the data that I want to show. We also knew that this problem is going to get bigger, because at that point, a lot of the systems is being modernized and they all want to use our brand new REST endpoint. So we went back to the drawing board. All right, so this is basically part 2. Surely somebody else had these issues. So what we have looked at so far was Hatios and Best Friends Forever. So what happens if you Google queryable REST? You're going to get to GraphQL. It's awesome and it's going to solve all of your problems. So let's start with a little bit of the history of what GraphQL is. GraphQL is created by Facebook and open source by Facebook. It's just a specification. So there's multiple implementations of GraphQL. It's been positioned by Facebook as an alternative to REST. It's actually now been hosted by the Linux Foundation and not by Facebook anymore. And it has many members that maintains it. It's specifically built for declarative data fetching, which is what our problem is. Facebook started developing this because of the increased use mobile usage that they had at some point when people started accessing Facebook on mobile. It also helps to have something that the front end can change at a different pace than the back end. And if you're a company that has multiple front ends, like a web and an app and a mobile web and maybe something for your smartphone, then this is something that can help with this. So it helps with rapid feature development because the API is queryable, the front end doesn't have to go and ask for a new specific endpoint that the back end need to develop. And this has actually been around for a while. Facebook started this in 2012, and it's been publicly available since 2015. So some of the benefits, like I've already mentioned, the data fetching, it solves the over and under fetching problem. This development speed, so rapid product iterations on the front end. And it has the benefit of having a schema and a type system, which is something that we don't have with REST. And if you want it with REST, you have to add it separately using something like Swagger or OpenAPI. So if we do a comparison between the two, there's a good website called howtographql.com. This is where I took this from. But in our example, basically, if you have a website, they would make a call to, let's say, a profile service. The profile service will give them the address of where the person is, so they'll make another call to get the person, get way too many fields back, filter out, make another call to the score system, get too many fields, filter it out, aggregate the lot, and display it on the screen. With GraphQL, you would make a call to a service, you would ask exactly what it is that you want, and the service will reply with exactly that. Which means that if you have another front end, like a mobile phone, they can use the same backend, but ask a different question, saying that I only want title and surname, and then the backend only replies with title and surname. So some of the concepts in GraphQL there's operations. Queries is what we've spoken about mostly, and then mutations is basically the rest of the CRUD operations apart from read, where queries is a read, I just fetch data. Mutations is an update, create, or a delete. So anytime that data changes, it's a mutation. And then there's also subscriptions. I'm not going to talk about subscriptions today because we don't support it yet in MicroProfile GraphQL. Then you get types, typically an output type. So if you do a query or a mutation, you get something back. Like if I say, I want a person, that person would be a type. If I want to create a person, I would provide an input, and that could also be a person. So these are, in Java terms, POJOs, plain old Java objects that we define a use case with. And then similar to Java, there's this concept of interfaces, there's enums, and then there's scalas, which is similar to a primitive type in Java. Okay, so let's talk about the specification, the open source specification under MicroProfile. So I'm hoping most of you know by now what MicroProfile is, but just a quick overview. MicroProfile is an umbrella specification, so it's a specifications of specifications, specifically for enterprise microservices architectures in Java. So some of the APIs under MicroProfile is similar to the ones that you get under the Jakarta. So CDI for context and dependency injection, JSONB for JSON processing, JAX-RS for REST endpoints, JSONB for binding. This all comes from Jakarta. And then there's a whole bunch of APIs that's now specifically for microservices architectures or cloud-based systems, doing health checks, doing security with JOT tokens, doing metrics. And we'll look at metrics a little bit. Fault tolerance, so to make sure if your microservices talk to each other that they can handle faults. Now, configuration, REST client, we'll look at that a little bit. Open API, we'll look at that. And tracing, we'll look a little bit on that as well. Now, GraphQL is not yet part of the MicroProfile umbrella specification. The process under MicroProfile, if you want to add a new specification, is basically you play in the sandbox where you do a POC and you prove a concept, and then you go back to the community and you present it to them, and then they say basically yes or no. And when they say yes, you go on to become a standalone specification, which means you're a specification under MicroProfile, but not part of the umbrella. And that's where MicroProfile GraphQL is at the moment. At some point, we will go back to the community and propose that MicroProfile GraphQL becomes part of the platform specification. The process that MicroProfile follows, or basically the outputs that you need to basically say that you have a spec, you can go and see the spec at this URL. But it's actually the actual specification itself, which is the written out words, which is usually done in ASCII doc and outputted to a PDF. The API, so typically this will be Java interfaces and Java annotations that's been used by the implementations to build implementations of the spec. A test kit, which we typically use test-ng, and for you to become an implementation, you have to pass all the tests in the test kit. And then before you can release a specification, you have to have at least one compatible implementation. And in MicroProfile's case, this is small I, which I'll show right now. So We're doing quite well on time. So I'm going to show a bunch of examples now. I want to see, is there any questions so far? Then we can maybe handle that before I dive into the examples. Otherwise, we can just go.
We can go over the examples. No questions, please.
Okay.
If you.
Right. So the examples is available for you in my GitHub repo. You can just go to my GitHub repo, GraphQL Examples. It's fairly well documented, so you should be able to get this running on your machine if you just follow the README. So I'm going to show this example in Quarkus. I'm hoping you know what Quarkus is as well. But if you don't know, it's a runtime also specifically built for cloud environments. It starts up very quickly. And it's very easy to develop in Quarkus. So I'm not going to go into too much detail, but what you can do is you can go to code.quarkus to kind of start with any application. You can see all the extensions that's available. It's quite a lot that you can do. So one of them will be GraphQL. So you can go and select the GraphQL one, and then you can generate your application. And that will give you a head start on your application. I've already done that, and I've built a little bit of the application. So I'm going to dive into the actual code. So this is the example application. I've already built it. I want to start off by showing you the model. So you'll see that I have a plain old Java object person that we're going to save to a database. If you actually want to see how that model looks like, in the target folder in the API docs, you can open the index.html, and this just gives you an idea of the size of this object. It's quite a big object. There's a lot of fields in it. It's a complex object, so it's an object that contains other objects. So it's a big model. Now, back to the code. What we have so far is a REST endpoint. Because what I'm going to do is I'm going to show you the REST endpoint, and then we're going to take the REST endpoint and convert it to GraphQL to show you that it's fairly similar. Because what we've done in the specification is we said that we want to be able, we want to allow developers that's currently building REST endpoints to very easily build GraphQL endpoints. So the programming model is very similar, and you'll see as we build this that that's the case. So if I just zoom this a little bit, so this is my person endpoint. You can see it's available under person. So this comes from JaxRS. I've added OpenAPI, which is one of the MicroProfile APIs that allows you to document your REST endpoint, to create a schema that allows developers to see this, to get a type-safe schema of this endpoint of yours. And then you can use something like Swagger UI to test the endpoint in, and that's what we'll do. So this is specifically to document this endpoint a little bit. All that I've done is I've injected person service, and person service is just a service that actually save it to the database. So this is just an in-memory H2 database for demo purposes, but basically just allows us to create or do all CRUD operations on a person. And then under person/ID, I will have the ability to query a specific person under that ID. So if you pass in an ID, I will return a person, marshal it over HTTP with JSON. And then you can get all the people by basically just returning all the people in a list. So it's a fairly basic REST endpoint. So what I'm going to do is I'm going to start Quarkus in dev mode. Now, Quarkus has this ability to run in dev mode, and then you can make changes to the code and it will automatically reload. I did see some issues with that when I was testing this earlier, so I might have to restart the server every now and then, but for the most part, we shouldn't have to restart it. So server is up and running. So if you now go to localhost 8080, you'll see just a static page just to give you an intro. So the first thing is we'll click on the REST link, and this Swagger UI is included with the the Quarkus JSONB extension, so you have it by default. And you can see that this allows me to document my REST endpoint fairly nicely. You can see I have a person service, which is the one that's persists in a database, and then I have a score service that actually not persist at all, it's just in memory. Because in our example, these are two different data sources, which we want to combine. You can also see that the schemas has been generated, so you can go and see this is how a person looks like, this is the fields on there, and you can drill down into all the fields, right? And this has been created by MicroProfile Open API. So let's test out this person. So let's see how person 1 looks like. So if I execute it, you can see this is actually what happened under the cover. So it's a call to this URL, which is the one that we've developed. And you can see all the fields that came back, which is quite a lot of fields, right? Because the person is quite big. And if I build a mobile site and I want to display the name and the surname and the status, I now have to filter out all of this. Plus, I have to make another call. I have to go get this ID here so that I can make a call to the score system, which is another system, to get, again, too much data. I don't want the ID, I only want the name and the value, aggregate it with the filtered data of this, and now I can display it on my screen. So the payload on the network is quite heavy. And this is the overfetch and underfetch problem that we want to solve. Right. So at the moment, this won't work because we don't have a GraphQL endpoint yet. So actually, this is going to be broken. This is actually not even there at all. We're going to add it now. So back to the code. What we're going to do is we're going to just copy this one. And you'll see I already have the package there, but I'm going to paste it and I'll call it person GraphQL API. Right, so we start off with what we've done for the REST endpoint, but what we'll do is we'll just delete all of this. We don't need this anymore, and we'll just say that this is a GraphQL endpoint. GraphQL API. We'll still inject the backend service because we still want to get the data from there. We'll remove this and we'll just say that we want a queryable API. So make sure that this person is queryable, and I'll still do it via person, and similarly here, make it queryable. Okay, and then we can obviously remove all the imports. Sorry, let me zoom in a bit. Okay, so it looks fairly similar to the REST one. It's the same methods with different annotations. But what it does allow me to do now is if I go back here, this should work now. Right, so now this is GraphQL, which is very similar to Swagger UI. It's just a UI to test your endpoints with. What I didn't show you previously is what you actually get is HTTP localhost 8080 Open API. So for the REST endpoint, you actually get this Open API YAML document that is the actual schema of your endpoint, which has been generated, and then this is just the front end on top of that. And similarly, there's you can get the GraphQL one. Let me actually just go and find the link here. Right, and similarly, this is the schema being generated. The only difference is that you don't need a separate API like Open API for JSONB. It's built in, and this defines your actual endpoints. Okay, so let me just close some tabs. So this allows me now to test my endpoint, and you can see similar to the Swagger UI, you have a way to actually go and browse. This is a person has an address has lines, right? I can browse the actual schema, but also because I have code inside, I have code inside here. So I can already see there's the two methods the queries I can do. So we can say, I want to do a person, I need to provide an ID. Let's do ID 1. But now the difference is that I can say, what is it that I want back? I want names and I want surname. And now I get back exactly what I'm asking for. So if I'm a mobile phone, the payload is suddenly much smaller. If you compare this to what we had here, which was very big. Right, and if you need more data, you can obviously ask for more data. So if you want the addresses and you only want the address lines, then you can ask for only that. Now, what I can't ask for yet, because we haven't coded it yet, is the scores, because we actually want to. You can see there's no scores field there, so we're going to quickly add that. So if we go back to the code, the scores REST endpoint was actually a separate REST endpoint. That looks like this. So we'll just grab this off here and paste it in here. All right. Okay, so we're going to inject the backend, the scores backend, which, like I said, is a different data source from the person. And then again, we'll remove all of this. But now we're not going to make this queryable. We're just going to say that even though there's no scores field on a person in Java, I want to add it to GraphQL. So I can here, now I can say add source. So when the source of the query is a person, then return person.get ID number scores. Okay, so this should be enough to, when I refresh here, to now give me a scores field, which I didn't have previously. Now I can say, again, I can query off scores that I only want, let's say, the name, or I want the name and the actual value of the score. So I've basically stitched two queries into one by allowing you to do something like this. And if you look at the log file, you'll see that when I do the query, both of the backends are being called. Now, what might happen is that the scores backend in our case could be a very slow system that's down every now and then. And we don't want to penalize somebody if they didn't ask for the scores to go to that. So if I query this with just person information, it won't make the call to that scores backend. It won't hit this method. Right, but if I do, it would obviously. So if I say scores and name and value, then I'll get the data back. Right, so I've shown you a basic query. I've shown you the stitching where we stitch things together. Now, what you can do as well in GraphQL is you might want more than one person. So what you can do is you can say, well, this is person 1, and also give me person 2, and we'll call that person 2. And for person 2, we don't care for the score, we only want the name and the surname, right? And now I get exactly that back. So I can ask for exactly what it is that I want. And this doesn't have to be only from one query, like a person. I can actually mix queries. So as an example, let's say we want to add, just for an example, a random number. So back to the code, I'll add a query which just gets a random number, just to simulate another query. And this random number needs a seed, and it will return a random number. So back here, if I refresh, I should be able to now say refresh. Why is it not? Did I not save? I did not save. Refresh. Right. Now I have a random number which needs a seed, and I can say let's make the seed 1, and now I get the 2 people that I've asked for and the random number back. So I can aggregate as many queries as I need to build the front end that I need to build, right? Which is quite handy, all in one HTTP call and exactly all the data that I want. Now, one of the big benefits, of course, is if we go back to the REST example and we actually execute something that returns a list, the problem is even worse, because if I only want all the surnames, of everybody in my database, then that's quite a lot of data I get back just to get one field back, because it's now in my database is 10 people. That's 10 times 70 fields, and I actually just want 10 fields. Now, similarly in GraphQL, you can query around a person, right? So we can say, well, I only want back the surname, which again, this is much smaller payload than the one that we've seen here. So you can query over one object or a list of objects. Right. One of the other things that we've done in the specification is that we, again, because we want to have the programming model similar to JAX-RS, and JAX-RS supports JSONB annotations, which allows you to annotate your POJOs with JSONB annotations, and that will help with the marshalling to JSONB from object. So you can hide certain fields or change the name in the schema, or provide a date format as an example. And so if we go here back to person, and we'll do the person ID 1 again, right? But now we'll just say, give me the names and birth date, which is the date. And you can actually already here see that that's the format that this birth date will come back in, right? Now, if I go to the code and we look at the actual person object, somewhere here is a birth date that specified this format, which I can obviously now change to something else there, or remove completely. So let's remove it now. It will go back to the default value, right? Which is year, month, day. Right. So and this is true for all JSONB annotations that will be supported. So you can do JSONB property and hide a specific field and so on. Okay, that's a JSONB support. One of the other things that we support is a default value. So let's say you want to get all people with a specific surname. Let's close person. Right, so let's add this in this method. And now you have this annotation called default value. And so I can add a query and call it persons with surname, or I can call it something totally different, like surnames, right? And if I didn't provide a surname, we will get Doyle. Otherwise, we will get people with a specific surname. So if I go back here, I should now have a persons with surname. Did I not save again? I did save. Oh, I didn't. I called it surnames. And so for now, let's pass in the surname of this. Let's see. Right, and again, I can say, what do I want back? So let's just get back the names and the surname. Right, so now I get a server error. I just want to see if it's the one which makes me need to restart. Like I said, there's some issue with the hot reloading on the database. Since I added the database, it started doing this. So if it happens, I just restart. I must go log a bug in Quarkus and see if we can fix this. It's something to do with the H2 database I'm using. Right, so now I get back a person with the surname of this, but if I remove it and I don't provide a surname, it should use the default, which is Doyle, and there's 2 Doyles in my database. Okay. Now, one of the other things that you can do in GraphQL that you can't do in REST is partial results on errors. So in REST, typically what happens is you make a call to the backend, something happens, an exception is thrown, it's typically being changed to some or other HTTP code, and on the client side you have to figure out what that meant. In our case, what we can do, if I do person again, I will do ID is 1. And we'll do names, surname again, just our normal one. We can add the scores. and name. But now I can maybe say blah, which is not a field. Right now, already here you can see that you can't do it because I have actual code inside due to the schema. But if I go ahead and still do this, you'll see that I get an error. This is not a valid query. If I change this to be valid again, right? So that's the first type of error. It's a validation error that you're asking something that doesn't exist. The other error is, let's say the source backend system is down. As I said, this is a separate system. So let's simulate it being down. So we'll just say throw score not available exception, and I will say throw new scores not available, and we'll just say score system down. Right. So if I refresh this now, you can see that I get the score system down error, but I still get partial data back because I can still get to the person. So at least I'm not failing totally. I just show the error of the score system. And depending on how complex your graph is and how many things you stitch together, you can have multiple errors and partial data depending on what you can and can't get. Right. So that's also quite cool. Then obviously, if the system is back up, you'll get the data again. So that's partial errors and error handling. For the next demo, I'm going to show you metrics and tracing, which is two of the APIs that's part of MicroProfile, like I showed you. So metrics allows you to add metrics to your system, and tracing allows you to trace it. So in the background, I've started Prometheus, which is a time-based database that allows you to store metrics in it. And I started Grafana, which is a dashboard system that I can build dashboard on top of Prometheus. And I started Jaeger, which is a tracing system. So that, I'm not going to go into detail of that, but that's running in the background. In fact, you can see it running here. Right. So now I'm going to add these two annotations, which comes from the metrics API. And let's add it to person. So the first one is add timed, and it will allow me to time how long it takes to get a person. And then the other one is a counted, so it will count how many times people this question is being asked, get me this person, right? So it just counts the executions. So if I go back here, so let's execute this a few times, 1, 2, 3, 4, 5. Right, and now we should start seeing it in the Grafana dashboard. It does take a while because it only refreshes every 5 seconds, but we should see the data coming through. Let's hit it a few more times. So this is specifically in Quarkus. It's not in the spec yet, the integration with metrics and tracing for that matter, but it will boil up to the specification at some point. I wonder why this is not working. Let's see, maybe I forgot to save again. Yes, I did. Sorry. So now the hot reload will pull that in. 1, 2, 3, 4, 5. And now we should start seeing the data. And metrics and tracing also works in JAX-RS. So you should see the data there as well. Interesting. Okay, I'm not sure. Oh, there it comes. So just take a while. So you'll see now that the person count is 15 because I've continued to test and test. But anyway, you'll be able to build a nice dashboard with all the stuff that comes with metrics for your GraphQL endpoint. So the next one is tracing. So for tracing, we installed Jaeger, and there's nothing more that we really need to do apart from adding tracing to your POM XML in Quarkus. By default, it will start tracing. So you'll see that I have a person service, and I can now find the traces. And here you can already see, because this has been active all along, all the times that I've done execute something. And you can drill down, and now you can see that we ask for a person, how long did that take, and we ask for scores and how long does that take. So this will build a nice trace for you. Okay, so I think we can close this one and we can close this one. So that's metrics and tracing. The next thing that we've done, also specifically to Quarkus, and also something that will boil up to the spec at some point, is integration with security. So what we allow you to do is, let's say only admin people are allowed to actually ask for a person. I can just do roles allowed admin. So this is normal Java security. And now this shouldn't work, right? Because I am not allowed to do this. I don't have the admin role. So I get an error. And similarly to all the other exceptions, if I only want the score part to be secure, I can add this to only the scores, right? So it means that I can get person, but only if I'm admin, I can get person and score. So now I should at least get person back, right? So now I get partial results back. I have the person, but I can't see the score, which is quite cool. So that's security integration. The other thing that we've integrated, again, also specifically to Quarkus, and I'm not sure if this one will boil up to the spec, mostly because bean validation is not part of the MicroProfile spec. So only once bean validation, or if bean validation becomes part of the spec, which I'm not sure if it would, we can actually boil this up to the spec. So what we might do in the spec is we might just say, if the runtime that you have has bean validation, you have to support it. But in our case, we've added this in Quarkus or in smaller I. So let's say I want to, in this random number query of mine, I can now say that the seed, the minimum amount, the minimum seed is 10, right? So if I go back here, previously I did a seed of 1, I should now be able not be able to do that. So if I say random number, and so let's start off with one that works. So 10 should work. I get a random number back, but now if I do 9, I'll get it again. Partial exception, so I can get what I can, but I get my constraint validation exception that comes from bean validation. So this goes for all the bean validation annotations that you have. You can use them. Right. So up until now, we've spoken about queries, a way to get data. Next, I want to show you mutations. So that is basically everything which is not a read. So update, create, and delete. So for that, we have this annotation called mutation. So I'm going to add 2 methods on our service. And right, so this is just update person, passing in the person that I want to update. And now I call the backend again. This is doing JPA to do the update, but I mark this as a mutation. And similarly with delete, I pass the ID in, I'm going to delete that, and I mark it as a mutation. And this is enough to now add it to the schema and allow me to actually do this. Right, so if I start off with a create, I'll create a new person here. And like I said, I have 10 people in the database that the start of it. So this will be person number 11. And I only added Phillip in the person that I provided here. So even though I asked back for names and surname, which I didn't provide, I can't get that details. So we can now go and update it to provide that details. And now I pass in the ID because this is an update. And now I've updated Phillip with the rest of the information that I want. And similarly, now I can go and delete Phillip, right? So for delete, we'll just pass in the ID. And the ID is 11, and we'll just get back the surname. And if I do it again, I'll get back null because I've deleted that person. So very quick, but just to show the rest of the CRUD operations is fairly easy again with GraphQL. Annotate your method with mutation. Right, so the next thing that I want to show is actually still experimental. It is something that will eventually also end up in the specification. We've added a small array to just kind of experiment with it. And once we're happy with how it works, we will move it up to the specification. Now, the first thing that I'm going to do is I'm going to actually switch on SQL logging so that we can see the SQL that's been generated by JPA. So in Quarkus, to do that, you can configure it here in your application config, and I can just say, let's switch that on. Right. So let's go back here before we do anything and just do a very basic query. We'll do person ID1, and we'll just ask for surname, just to keep it simple. Right. Now, you can see that the log file actually shows me what is happening in the background. Now you can see that the query is not optimized because I only asked for surname, but I'm asking for quite a lot of details in the back. Now this context object is exactly to solve this problem, is to give a developer the context of GraphQL so that I can optimize my backend query. Now the backend could be JPA, it could be plain SQL, it could be NoSQL, it could be another REST service. So whatever that is, but give you the information to be able to do that. So if I go to the actual backend service, which is this one here, the get person just does a EM find, which is plain old JPA. But now I want to be able to do something better. So what I can do is I can inject the context. And as I said, this is still in small rise, so it's not yet in spec. And this context is obviously per request, and I should be able to do something like this. It actually has quite a lot of things on there, so you can get a lot of information from the context, like the arguments or the field name, the operation name, the path, the actual query, so the full query that was asked, the full request, which is basically the query plus the path plus the operation name plus the variables. But what we're interested in is the selected fields. We are interested to see what is it that what did this person ask for. And so I'm just going to print it out so that we can see what it is. So let's do selected fields equals and selected fields. Right. So obviously using this, then you can build a better query to pass in here. So let's see if this works. If I query this again, let me clear this actually. So let's do this. So you can see that I've only asked for surname, which means it allows me to build a better query and optimize my backend call. So again, let's clear this again. If I ask for surname and names, then the context will have that in. So that's the idea of this context. This allows you to anywhere downstream inject the context and get information from it to optimize your downstream queries. Right, so that's context. Like I said, it's still very experimental. But the next thing I want to show is that's actually up until now, I've shown everything that I wanted to show on the server side. I want to now show the client side. So I'm going to just, in fact, let me restart the server. So we're going to keep the server running as it is now, and I'm going to open the client. Now I've also used Quarkus for the client. And we're going to do the same as what we've done for the server. I only at this point have a REST service. Now this is coming from MicroProfile REST client, which is part of MicroProfile and allows you to build REST clients in a type-safe manner. So you can build a REST client by just annotating an interface with register REST client and then basically saying what is it that you want to call. So in this case, the person is a much smaller object because I don't want to get all the fields from person. In fact, if we go here and we look at the client API docs, you'll see that in comparison with, if you remember the server one, this is much smaller because the client is only interested in these. Now, with REST client, you can now basically build that, what the person means for you. Only provide an interface. You don't have to provide an implementation for that. And then I can inject that interface with just saying at inject and add REST client and make the call. Right. So if I run this system now, let's hope this works. In fact, no, I'm going to run this here because otherwise I'm going to get a port clash. So GraphQL example, and then Quarkus client. Right, so we can do Java -jar target and a Quarkus client snapshot runner, and then we pass in the ID of the client you want to see. Right, and now we got the person back. What happened in the background is that the whole JSON was streamed over the network, but only these parts were picked and populated in this person because that's the ones I want. But I haven't saved the network yet because that's the problem we're solving with GraphQL. You can also see that scores is not there because I actually now have to get the ID of the person and then make another call and get the scores and then populate the person. So 5 minutes before we have questions, we're nearly done. So I'm going to again copy this person REST client. I'll do person GraphQL client, and I'll show you again how the development model is very similar to GraphQL Jackson REST. So we'll start off with GraphQL client API. We'll say that this is the query that we want to do. So we'll do add query. And what will happen in the background now is that we will build a query based on this person object, which means the network traffic is actually optimized. Now, let's print that out as well. So the inject doesn't work yet because this is not a Quarkus extension yet. This is just pulling in the small I API. So once we've built the Quarkus extension, you'll be able to inject it similarly like the REST client. And now I can do the same as I've done here, except we'll say that we will get the GraphQL client, get the person of that. We'll call it GraphQL client, and let's print that out under GraphQL. All right, so if I compile this, and I'll run the same query, and now you'll see that I get the same data back, with the difference being that what you see here is what was on the network. So I've optimized the network, plus I could get the scores. I could stitch these two together. But again, the programming model is very similar to what you are used to with JAX-RS. Right, the last thing that I want to show before we go to Q&A is one of the things that you get built in with GraphQL is the ability to ask yourself questions. So you can run a GraphQL query against the schema to understand the schema better. So you can do something like this, where I basically say, in the schema, show me all the types, give me their names and their kind. And now I get, there's a type of address, it's an object. There's an address input, which is an input object, and so on. So that's quite cool to be able to introspect yourself. And again, this comes out of the box. You don't have to do anything. Right, so I think that's basically my demo. I know I went quite quickly, but again, this is available in my GitHub. Go and check it out. There's a wildfly example as well. I don't think it worked at the moment because I've just done the upgrade to the database. Previously, I was just running it in memory. So I'll fix the wildfly example. But then just to wrap it up, let's do this again. So I've shown you the examples using the small array implementation, which is the one that I'm working on. And that implementation is used in Quarkus, like the demo I've shown you. It's also used in OpenLiberty from IBM. And we are busy adding it to Wildfly as well. And then there's another implementation called Speaker, which you can go and find under that URL. And Speaker existed before we started this whole process of making this a standard. So a lot of the stuff that you see, the concepts that you see in the spec actually comes from Speaker. And that's it. That's me. So any questions, we can do them now. Otherwise, I'm available. You can find me online either on my blog or on Twitter for any questions.
Wow, that was a really nice presentation, Philip. Learned
Thanks.
a lot about GraphQL. I'm going over the questions that I'll be able to see here on Q&A. So lots of questions around specifics on GraphQL. For example, how the front end consumes an API with GraphQL. That's a question.
Okay, so let me answer that one. GraphQL is actually very well supported in other languages. So I think Java is a bit behind in terms of supporting GraphQL, where something like JavaScript has very good support for GraphQL, and it's been used much more than in the Java world as well. So what we're trying to do is to bring that to the Java world with this specification. Our library is built on top of a library called GraphQL Java, which is a much lower level library, which you can also use to build endpoints. But like I said, we've tried to make it this code first approach similar to JAX-RS, and we've built on top of GraphQL Java. But most other languages have support for GraphQL in some form or another. So depending on, typically your front end will be JavaScript, I assume. There's very good support for this, because this is where Facebook came from, is from a JavaScript world. So it's very well supported in JavaScript. I think that answers the question, right?
Yeah, it does. There is also another question saying if it only works on Quarkus, and I think you already answered that. Does GraphQL get errors on multiple calls altogether, or just a single failure on the first? That's another question.
Yeah, so that's a good question. So let me just simulate an error quickly. I'll show it to you. Person ID as one. Right, so we'll just do surname, and then we'll do scores. And now I'll just go and simulate a failure on scores again, right? So this one should work. So if I quickly go back to the code, the server side, which is here. So I'm just gonna do throw, yeah, I can just do the same as what we've done. Okay. Why? I should actually create it now. Block. So this should simulate the error again, and you'll see, let me close this. You'll see that the errors is actually an array, and it has quite a lot of information in there. It's got the message, which, depending on the type of error in Java, in our case, scores not available exception is a checked exception, so we will show the message. If it's a runtime exception, we show a generic server error. And all of that's configurable. So you have an allow list and I can't remember what's the allow and deny list, which allows you to change the behavior of whether or not the message should be shown, because you could spill sensitive information to the client that you don't want to. So you can control that with config, MicroProfile config. You can also see the location of this error. So you can see that this one came from line 4. Column 5, which is exactly there where the problem is. You can find the path, which is person scores, and then this extension is specifically to small array. The spec allows us to add anything in the exception, so we just add the actual exception in there. But if I have another error, there will just be, this is an array, there will just be another one of these showing me exactly where that error happened with the line number and the path and the actual error. I think that answers the question, right?
Right. Also, there are two questions here that I can group together. Something like, for example, the unneeded fields. I mean, if the user depopulates, if the REST API provides some sort of conditional query parameter like expected fields. Also, there is one about data formatting, like what happens if you have like dates or monetary values on GraphQL. So,
yep. So the dates one, I think I've shown in our support for JSONB. So the example was the birth date here, which is formatted, right? And in the code, the person object, no, not in test, in the model. And this is for client and server, right? I can do something like this. So I can format, and the same for amounts and if you don't have JSONB, you can do. We have our own one, so you can do date format, which is doing exactly the same thing. The only difference with this one is that you can actually do it over a list. So I can do something like. Let's say you have more than one birth date, which is not possible, but just to show you what you can do. So you can do something like this and provide the date format inside a list, which means we will apply it for all the elements in the list. But all formatting, dates, numbers, number formatting is done via JSONB or our own annotation. I think that answers the question. The first one. What is the first question?
It is about the exceeded fields. Like if you have a conditional query parameter like expected fields, and the implementation populates the object accordingly, so the user don't get unneeded fields. And can this be an alternative to GraphQL or for legacy systems? That is like the question.
I'm not sure if I follow the question. Like I've said in my presentation, one of the things that we did before we got to GraphQL was exactly using query parameters to allow you to do filtering. The problem with that is that it's still it's very manual. It's not standard. There's no standard way to do this in REST. So you're gonna create some dot notation to specify a complex graph to be able to say this is the field that should be included. It might be the person's address line, right? So it's a person.address.line, and what if it's a list? So what if I have multiple addresses? So it's a person square bracket 1. It's a very hard thing to define because it's not defined in REST, and that's why we said that we can build it ourselves, or we can just use GraphQL, which is how we got, how I got to GraphQL. I'm sure you can build it in REST as well. We decided not to, right? And we decided to rather use something that's already out there and support it.
Right. And just a final question. There is a group, actually, of group questions like, does the GraphQL take over all the API world? Also, if it is GraphQL replacement for REST or just improvement? So some questions related to GraphQL between REST and GraphQL.
So I don't think we know what the future holds. I think that there's it's not going to replace anything. Just as REST, even though it's more commonly used than SOAP, you still get SOAP services because there's still old system, there's still legacy. So I do think it is a better way to build APIs than with REST. I think it's going to take a while to overtake REST as the most common way to build, because most APIs is built in REST. I think in other technologies other than Java, it's much further along in terms of usage. And obviously what we're trying to do is just to start exposing Java devs to GraphQL. And that's why we've done it in a way that allows them to just use all the knowledge that they had from JAX-RS, but built a GraphQL endpoint. But who knows? Maybe GPRC or whatever the next thing. There's so many other technologies. Obviously, our hope is that GraphQL will do well in the API space. But yeah, I don't know.
Okay, that was awesome, Philip. So, guys, if you guys have any questions, please reach out Philip on his Twitter or his website, right, and the GitHub page. And thank you so much for the presentation. Learn a lot about GraphQL, Philip, and
Thank you, and thanks for the opportunity.
MicroProfile. See you.
Bye.
Bye. All right, everyone. So I'm just going to call it to stage Larry. He's going to be our next speaker. Let me see if Larry is ready to take.